Okay, in today's experiment we're going to try and work out the capacitance of a capacitor using the energy of a capacitor. So I've got two series of cells here, so 12 volts to supply this capacitor to charge it. It's going to charge pretty much instantly. Got a voltmeter attached to the capacitor at the moment. Then we're going to discharge across a resistor, but going through the joule meter to measure the energy. And we're going to use E equals half CV squared then to measure the capacitance. Now the capacitance written on this capacitor is 4,700 microfarads or 4.7 millifarads. So see if we can get somewhere near that in this experiment. So let's connect the check the positive to positive, negative to negative, and charge a capacitor. So you can see that it's going to charge up to 12 volts fairly quickly, but not instantly really, I suppose. There's a bit of resistance there in the circuit, but so it'll go up to around 12. Now you've got to be careful when you disconnect things here, because if you just disconnect the cell, then the capacitor will start discharging across the multimeter, I think. So best to disconnect both at the same time, really. So we've got a value there of, oh, there you go, minus 12. So if I disconnect both at the same time, it should be there, so 12. So now there's 12 volts across the capacitor, and if I take some of these wires and reconnect the circuit, so now if I connect positive to positive here and discharge now across the resistor, we should be able to get a reading here for the energy. Okay, so should be a few hundred, we shall see. And the resistor I'm using here is 2,200 ohms, although we're not really going to use that in this experiment today. It just changed the rate at which it discharges, essentially. So there it seems to be flattening out to around 320, so 319. So if we use half CV squared and rearrange the equation, you've got capacitance equals 2 times the energy divided by the voltage squared. So let's have a little look at that. So 2 times 319.9 to the minus 3, and then divided by 12 squared. So there we go, we've got a value there of 4.4 times 10 to the minus 3. So that's not far off, really. The nominal value of this capacitor is 4.7 millifarads. Okay, so the only thing I've found with this, though, it is a little bit difficult to get anything like a repeat the same values. So I've done this, if you just come in front of the camera, I've done this a few times with exactly the same kit. I varied the voltage. I found that we get closer to the value with 12 volts for this capacitor, but I'm getting values of between 5 and 4.5, 4.4 times 10 to the minus 3. So there is a little bit of variation. I think unplugging the battery and the multimeter is a bit of an issue at times. Maybe just a switch would be better to use for that, I think, than the cumbersome way I did it. But there we go. So we managed to figure out there that the capacitance of the capacitor. In the CPAC for AQA, you do this generally using the time constant method. But this is a useful thing, and I know it comes up in the WJC course. Okay.